Good morning, everyone. I am Tomislav Golubovic, and if you've been following me on LinkedIn, I did a webinar late last year about Dynamo and Advanced Steel working together, and as a result of that, I did 3 LinkedIn articles going through the tutorial, and we did this tutorial inside the webinar, but I guess to save you from digging through the webinar, I'm doing the whole tutorial now as a quick little sort of 5 or so minute video. And then this way, if you're using Advanced Steel and you want to automate some of your functions, then have a look at this. We're going to create just a very basic portal frame kind of structure with a pitched roof on it. And then you can see what it looks like inside Dynamo and Advanced Steel, and we'll make some changes. And again, subsequently, you'll see what happens on one will flow through to the other. So if you are on subscription and you have Advanced Steel, you will see that there would have been an update for it for adding in Dynamo. So this is Dynamo after I've launched it from Advanced Steel, and you can see here we've got some beams, plates, and utilities for it as well. So that way, I guess you know if you're running Dynamo and Advanced Steel, you will see the Advanced Steel DLLs located there inside Dynamo. So just to show you, I have in the background there Advanced Steel running as well. So what we need to do is generate some inputs from users that are going to be using it. So number is one of them, and then it will place a number node in there. So when you double click on the heading there, you can change the node name. So I'm going to call this building length. I'm going to Control C and Control V that. So now I've just copy pasted really, and I'm going to say building width. Okay. And I'm going to copy paste as well and call this number of bays. So there is a few more nodes to put in there, but for the time being, we're just going to do building length, width, and number of bays. So to get started, let's chuck in a building length of 30 meters. Let's make it 12 meters wide for argument's sake, and let's put in there 5 bays, which ultimately will give us 6 meters. So we've got to do a little bit of calculation as well here first before we dive into it. So I want to do a division function. So I've got my 2 inputs and then obviously my output. So I'm just going to pin that resulting value there. So the first value is 30 meters and we want to do it over 6 bays, and there's our result. Okay. So if I change that to be 6 bays, then obviously the result changes to 5 meters. So I'm going to go back to 5 meters. So next thing is to do a range. So range means that we have our start. So the default value is going to be 0, which I'm going to leave. If you wanted to, you could put in a new I guess value for where you wanted this structure to start, but for this exercise I'm just going to say 0. The end value is going to be 30 meters and the step value is going to be 6. Okay, so here you can see this would be, you might think of it as our x coordinates. So we're going to have a point at 0, 6, 12, 18, 24 and 30 meters. So if we come back and change this base to be 4 again, then you can see the values. It's going to step every 7.5 meters. Okay, go to 5 and go to 6. So all of our values are going to keep changing. This is where the fun starts happening. We are going to put in a point by coordinates. So x, y, z's. So our x is going to be 0. Our y is going to be the step value. And if I keep that there, you can see we've got our different x, y, z values. So our x is 0 and our y is going to step through the range. 0, 5 meters, 16, 15, 20, 25, 30, as is our list here. And if we zoom in to the actual model, you can see the red dot there. Okay, Plus as well, you can see there's our different step function. So if I change the building to be 36 meters, you can see our values change to 36. 30 meters, and with 4 bays. Okay. Okay. So just looking at sort of side on there. So let's put that back to 6. So we've got one set of coordinates, and you can see this is where that sort of UCS icon attaches itself to that point. So we're going to copy paste that again. Okay. But we can do our building width now of 12 meters in the X direction. You can see there's our building laid out. Okay, so they're the base points of our columns. So let's put in another number. So I'm just going to copy paste this one again, the building width, and I'm going to call it wall height. So that's going to be the height of the columns that we're going to use. So I'm going to copy the first one again, and then I'm going to link the wall height to be 12 meters, and we're going to copy the second one. So nothing else is changing other than adding the wall height to the 12 meters. And then if we look at the actual nodes, okay. So again, let's look at something like changing the building width to 24 meters. You can see our building changes, and let's make the wall height 6 meters. You can see we've got a fairly sort of squat looking structure there. So now what we're going to do is copy that wall height, and I'll call it the roof height. Roof, H-E-I-G-H-T. So the roof height has to be more obviously than the wall height. So I might make that 8 meters. So this is where things might get a little bit tricky for some people. So I'm going to copy paste that and stretch it out here and just remove that node. So this is going to be the point of our roof. So I'm going to drag that down. Now, again, we're going to need to do a little bit of division here. So I'm going to copy paste this divider again, get rid of the nodes, and I'll put a code block in here of 2. So what we're going to do is take our building width one way, divide it by 2, okay, and we get a value of 6 meters. The reason we're doing that is obviously our roof is going to be in the middle of the building. Okay, so because we know that these are in our Y's, so I can turn around and stick a point in there. Oops. Sorry, X. There we go. So you can see there's that point of where our roof would be in between the other 2 bays. So our Y coordinate is just going to be this range value, and our Z is going to be the roof height. Okay. So looking at it sort of end on there, if I change the roof height to be 12 meters, then our members change, or our points change, sorry. So let's just go back to 10 meters, make it. Okay, so now that we have our points, we could jump into advanced steel here, but there's going to be nothing because we haven't connected or run anything yet. So what we need to do is start adding some straight beam nodes from the advanced steel DLLs. Okay. So looking at this, that's 0.1 and that's 0.2. So our start point of the beam is there and the end point is there. You can see nothing has been drawn yet. Okay, and we also want to do the vector. So if you look for vector, and it is vector z-axis. So the orientation, and you'll see once we get the steel beam in there, you'll see what changing that does. So we don't have anything in advanced yet. We've just got these lines drawn between the two inside Dynamo. So the next one is what we want to do is adding a beam set section. So if we look for set section, okay, so it's a beam element. Now the section name, this is where things are going to get not really tricky, but you'll see what you have to do inside Advanced Steel. I'm just going to minimize this and jump into Advanced Steel. So we've got some beams in there, but they're not the right ones we want. We jump into Management Tools, and then we're going to start looking at the tables. So you go into the Table Editor, connect to the tables, so open ODBC, and then we're going to search for, in the filter here, master. Okay, and then go to the profile master table. And I'm in Australia, so I'm going to look for AU. Sorry, AS. Where is it? So something, I'll do a beam just for argument's sake. So this, the type name text is the one that you want to take note of. So you can copy that. And we're going to jump back into Dynamo. And I'm going to put a code block in. Okay. Hashtag @ and then it's Alt 0167 @ hashtag. Now I'm just going to minimize this and go back to my master tables, and I'm going to search for that value. This is the table name I want. So I want to look at the type name text of universal beams under the AS and ZS, and this is the table we want to jump into. Once we do find that table, then I look for the beam that I want to use. So I'm going to do, I don't know, let's do a 310 by 46.2. So the section name is the one you want to find. You copy that, and then we can close that, minimize that, go back to Dynamo, paste that value, close it off, okay, and then that's the section name that we use. Okay, so when we go back to Advanced Steel, you can see under the advanced properties, Australian Universal Beams 310 UB 46.2. So what I'm going to do is just switch to Dynamo again. And if I change my building length, so while I'm typing this in, look at the left side of the screen. So I'll change that to 36 meters. And you can see in Advanced Steel, it changes. So let's go back, let's make it 24 meters. Because I've got it set to automatic, I don't need to go through and do anything other than click back in the window. Down here in Dynamo, I can set to manual, and then I can run it. So if I make that 30 meters, click over here, you can see nothing happens. If I click on run, then you can see it happens. So it's really up to you. As the scripts get bigger, the automatic might be a little bit too heavy, and then you can just set it to manual. So let's make it 5 bays. Same thing, look at advanced steel, 5 bays. So this is where I was saying about with the whole vector z-axis option here. So let's go back to vector. So let's make it x-axis. So if I replace it in there, it might even be the y-axis. You can see the beams rotate about an axis. So again, it's completely up to you. Depends how you want to model it, run it, however your structure looks, all that kind of stuff. You've got the options of your 3 different axes in there. So we don't need those 2 anymore. So that's one side of our structure. So what we can do is copy that again. I don't need those 2 start and end points anymore. I want the other side. So I want start point there, end point there. Okay, and then we can also do the same thing with our set section. Straight beam connects to it, and we're still going to use the same section. Come back to advanced steel, and then there's our second wall. So now we start looking at this roof area. Okay, so this is, I think, what I like about Dynamo as well. If I pick on a coordinate, it's going to show me where it is. So I'm going to copy that function again, just get rid of those, and I want to connect this point to our roof. There's one side, and again, same thing, I'm going to do the beam set section, connect this element instead. So again, I'm just going to keep that one beam, that one code block, just because it makes it easier for this. So let's do the other side. Start point will be this side. End point will be the top of the roof again. And now straight beam is connecting everything. So you can see here in Dynamo, it looks a bit messy. And then there's our basic structure. So while I've been doing this, in the background, you can see in advanced steel, it's just popped up now there. There's our structure. So I'll do the same. I'll minimize this a little bit so you can see it. And then let's come over here. So just to make things interesting, let's make this 24 meters. Jump back into advanced steel, click. There's our building. So you're asking now, I guess, what happens with connections. So let's just minimize that. Connections in here inside advanced steel are linked, I guess, to each of these elements. So if I look at my connection vault and I want to do an apex haunch on this roof, 1, 2, and then there it is. Now I'm just going to leave the defaults. I'm not interested in going through and tidying that up for the time being. And then let's do a knee frame. Okay, and let's do the same thing to the other side. Okay, so you can see there, out of the box connections, not really too fussed on making them look pretty or adjusting them. They don't look too bad. The bolt centers are okay. So when I go back to Dynamo now, so let's make the building width, let's go back to 12 meters. I've okayed that. Click back here in advanced steel. and it's going to turn around and keep everything connected. Okay, I haven't lost those connections. You can see there, it's all good. So if I turn around and maybe change the wall height to be, let's go 7 meters. Okay, once I've clicked back in Advanced Steel, it's just going to turn around and change it because these connections are connected to my columns and this roof beams. I don't need to turn around and really do anything or change it. Okay, so this all looks a little bit messy, but what we can do as well is turn around and group items into sort of user input groups. So I want to highlight to people that these 5 values are the values that you want to change. So you can just select them all, right click, create a group, come in here and say user inputs, and go OK. All right. Then the rest of it is really just linking between the two. It looks messy, it's up to you. If you want to turn around and make them a bit neater, then you can turn around and do that and just adjust everything. So I drag those out there. So this is always going to be part of this, part of these code blocks here. These are really just the points. Sorry, the beams, and then you got all the points here as well. So depends on how pedantic you are. You can turn around and adjust all of these, but it's really up to you. So hopefully that's been a good introduction for everyone to use Advanced Steel and Dynamo together to automate a lot more of the functionality that you can do with Advanced Steel. Thanks.